Hi, I'm Jan Witkowski. I'm Director of the Banbury Centre here at Cold Spring Harbour Laboratory. This is the afternoon of the first full day of the 79th Cold Spring Harbour Laboratory Symposium on Quantitative Biology. And the topic this year is cognition. I'm very pleased to have with me Matthew Rushworth from the University of Oxford, who combines. Well, why don't you tell us, Matthew? You were fortunate to speak on the first afternoon, so you can now relax and we can go to the wine and cheese and enjoy yourself now.
Yeah, I'm looking forward to that. So I guess the sort of things that I'm interested in is how we make decisions and how the brain mechanisms that underlie our ability to make decisions. So what we're doing when we're weighing up one option and considering its value and comparing that with the value of some alternative course of action, and how we come to a resolution, a decision about what's the best thing to do.
So what sort of experimental tests do you do? You present a subject with a choice of equal weight, or how do you set about doing this analysis?
So in a way, what we're interested in is every type of decision you might make. So you brought up the wine and cheese party that we're hopefully going to soon. When we go to that, hopefully there'll be a choice of two different wines to drink, perhaps. And when you're confronted by that choice, what you're going to summon up is a memory of how good, say, that particular white wine has been the last time you tried it, that particular red wine has been on the last time you tried it. And then you're making some comparison between your internal representation of the value of those two different things. And what I'm interested in is how that comparison process works. So when we conduct an experiment, unfortunately we're not able to ask our subjects to drink wine, but we're instead giving them a really simple decisions to make, just between two different visual stimuli normally. And the subject makes the decision in order to win some points. These are human subjects. And we scan their brain using fMRI while they make that decision. And then we ask them to take a very similar type of decision again a few seconds later, and then again a few seconds later. And by repeatedly asking subjects to make 100 or so simple decisions, we're able to gradually average together the activity that is occurring each time the subject makes that choice.
I mean, that sounds fairly straightforward. You're presenting them with just an alternatives.
That's right.
And I thought one of the most interesting things you were doing was you add in a third possibility to confuse the issue or to.
Yeah. So the idea behind this is that we think there's a particular part of the brain called the ventromedial prefrontal cortex that carries out this process of value comparison. So it's comparing the value of choice A with the value of choice B, and it's eventually coming to a conclusion about which one would be the better option to take. And if we use fMRI to record activity in this brain region, we can see that the activity there is correlated with the difference in value between those two choices. And we think that the difference in value between the two choices is the key decision variable. That's what defines how much better one thing is than the other. So the value difference is what drives our choice, and the activity in this brain region co-varies with that.
Sorry, and in the experimental setup, one is made more favourable than the other because it can get more points for selecting.
That's right.
That.
Yeah. So that's something that we organise as experimenters. Will happen is that sometimes the one choice is going to have a higher magnitude of points associated with it, or a higher probability of points associated with it. And the subjects have learnt about these contingencies before they come into the experiment. And so what we were doing in the experiment that you mentioned is trying to see what happens if we add into the mix a third option. And what we're interested in, what we've been intrigued by, is the way in which this value comparison process gets subtly altered as there are more and more potential options to consider. And it turns out that the value comparison process becomes a bit more inaccurate when there are multiple alternatives to consider.
And by inaccurate, you mean that that the subject more frequently chooses a lower value than the higher.
Exactly.
value.
Yeah. So if as in our experiments, we can actually identify which is truly the objectively better option and the worse option. On occasions, when we add in a third option, the subjects can become a bit more inaccurate in making their choice between those first two options. So it's a little bit, perhaps one way of thinking about why this might be one more sort of everyday situation that this might relate to is, say, if you were out shopping, if you were out buying groceries. So you might have a particular type of I don't know, let's say bread that you wanted to buy, and if there are just two choices, your preferred option and your less preferred loaf of bread, then you're going to make that choice accurately. But the claim is that when you make that choice in the context of multiple different varieties of bread, somehow or the other your comparison mechanism ends up being confused by the multitude of options. So the idea is that perhaps if you had more opportunities, more potential choices, you might end up being a little less satisfied with the choice that you end up with.
That sounds pretty sensible. And so in the experimental setup, what's the relative value of the third? I think you called it the distractor, compared with the sort of A/B choice.
So what we've found is that the most distracting type of third option is one that is very low in value, and we think in that type of situation, when you have two good things to choose between, a very poor third alternative leads to you ending up sometimes making more inaccurate choices.
That seems rather counterintuitive. You'd have thought that if the distractor was closer in value to the A and B choice, that you'd spend more time taking C into account in making your choice.
So certainly, as that third option, let's call it C, increases in value, you do become more likely to end up choosing C, for example. But if there's another type of error that you can look at, and that is inaccuracies in your choice between A and B. So if A is better than B, then B is the worst choice to take, and the proportion of B choices can subtly increase when the C option value decreases. And the reason for this, we think, is because the comparison process is being mediated by an inhibition process. So we can imagine two pools of neurons representing choice A and choice B, and they're fighting against one another. So one pool of neurons is inhibiting the other pool of neurons, so that ultimately only one of the pools of neurons ends up being active and the other one becomes inactive. And it's the inhibition process that mediates this competition process. So it might end up with A ends up being active, or B ends up being active, but the other option becomes inactive. And the reason why a low value third option has this effect is because it contributes, it sends an excitatory influence into the inhibitory pool. So if it is a poor value third option, it doesn't add much to this inhibitory pool, and it's the inhibitory pool that actually mediates the decision process. So if there isn't much inhibition going on, then the comparison process between the first two options doesn't work so effectively. That's the logic behind it.
Sounds a bit like political elections, where you have the Tories and Labour, and then you toss in the Lib Dems, who are actually not a very, I guess people in the UK consider this, not a very strong choice, and they can spoil the success of one or other party.
Yeah, I think that's an interesting analogy. There are other analogies that you might also be able to make that might be less politically contentious. I mean, I think in some ways, although you're absolutely right that there's something counterintuitive about this process, and that's of course what made it interesting to us, there's also some situations in which it might seem a bit more intuitive. Imagine if you're a foraging animal and you don't have long to make a decision, because there's a risk of losing the options. Perhaps they're not going to be there forever. In that situation, you don't just want to make the right choice, but you want to make the choice quickly as well. And so if you have two good things that are very high in value together, and you know there are other things in the environment that are terrible, well, actually it's quite a good satisfying choice, if not an optimal choice, to choose either of those two good things.
Right.
So it does have a certain logic to it.
I think one example you gave was the length of time that an animal should forage in an increasingly poor environment rather than risk moving off to what might be a better environment.
Yeah, so that was another line of experimentation that we're interested in at the moment, where we're interested in how an animal, or indeed a human in our investigations, has a sense of how well they've been doing recently. We think this is a different type of decision process that depends on different brain areas and different types of mechanisms. And the key idea here is that in some situations there isn't really a choice between two different things. Instead, there's a choice about whether or not to carry on doing something that you're already doing, or whether to switch and try and engage in some perhaps more profitable behaviour elsewhere. And in order to guide this type of decision, we think you need to have an estimate of how well you've been doing recently, and some more longer-term average sense of how well you've been doing over a longer time scale. And by comparing these two things, you can work out whether it's worthwhile carrying on as you were, or whether you should switch and do something else.
Does that, I think of the example I just gave, the foraging animal, do you also need, you must presume then, part of this computation must be some estimate of how successful it's been in the past for you to leave this point to risk going some distance away where there may or may not be, things may or may not be better.
Yep. So I'm sure you're absolutely right that that's an important part of the process, and that ability to learn this information and actually relate it to particular cues in the environment, and to then recognise those cues when you see them again, telling you that you're once again in the same type of situation, is going to be really important. But at the moment, our investigations are at a slightly earlier stage, where we're just trying to see how it is that our human subjects are online trying to estimate how well they're doing now, and how well they've been doing over the longer term, and how they compare those two different estimates. So I'm sure once you've got those estimates, maybe you can relate them to a longer term cue, and that would be a good line of research to follow up next.
This thing about making choices reminds me of the what's it called? It's the opposite of the grass is greener on the other side of the fence. That when you have a choice and you make the choice, generally you're much more satisfied having made that choice about what you've chosen than you were before. You presume you're not looking at the sort of post-choice.
So we do sometimes. There is indeed evidence for just that type of phenomenon. I mean, there are some situations where it does seem as if, having made a particular choice, we then become somehow more likely to commit to that choice again in the future. And it does seem as if some of the same brain mechanisms. It does seem as if some of the same brain mechanisms are maybe assessing the success of the choice that we just made in order to repeat it again, or to switch to some alternative. And so there is indeed a link between these two types of things. We know that the same anterior cingulate brain regions that are mediating this second type of decision are evaluating the outcome of a choice, as well as being active before the choice is made.
You're carrying out these experiments in a laboratory setting, or at least in a carefully controlled setting.
Yeah.
Do you think you're going to be able to devise sort of real-world observational tests with that? And by observational, I mean just looking what people do when they're presented with a situation, like whether they should run for a bus or should they wait for the next one.
Yeah. So. That's a very good question. I mean, I guess that sort of part of the art of designing experiments like these is to sort of drain these decision-making problems of all of their colour and interest, and to make them repetitive in order to gather consistent data time after time. And the reason for doing this is that our tools for measuring neural activity are relatively insensitive. So we have to average together activity recorded on multiple different occasions and multiple different simple decisions. But one way that we can try and see if these measurements of these rather artificial types of scenario relate to real-world behaviours is to give our subjects questionnaires asking them about other types of decisions that they might make. And we can then try and see if, say, a particular way of performing on our very basic, simplistic experimental paradigms might relate to some of the things that they might habitually do in a more real-world setting.
I guess one final question just occurred to me, thinking about the talks this morning. I guess who was it who spoke about C. elegans, not Corrie.
So there was Sean Lockery.
Yes,
and
basically, the worm's swimming along, and it makes a decision to change direction and go off in some other direction, or even the fishermen and their search patterns. For C. elegans, is there any relationship between the types of decision or the neural structure system that the C. elegans uses to make those sorts of decisions?
Well, on the one hand, there are sort of radical differences. So, with C. elegans, you've got an animal with 300 or so neurons, if I understand correctly, whereas in humans, we're looking at people with orders of magnitude more neurons. But nevertheless, there's something at a more abstract conceptual level. I suppose there are some basic similarities in the models that we use and in the models that were being used this morning in the talks about the worms, where we're looking at neurons or pools of neurons competing with one another in order to bring about a decision process.
Yeah, rather like what Corrie was saying.
Yeah.
Anyway, thank you very much, Matthew.
Okay,
I think it is time to go to the wine and cheese.
Great. Okay, thanks very much.